Hello dear students, in our previous video we have learned about the steps of viewing transformation. So what was the first step? We have to select the window in the world coordinate system. Then we have to translate the bottom left corner of the window to the origin of the world coordinate system. Once the translation is done, then the second step is scaling or resizing as per the size of the viewport. So in this image, we have scaled the window. And after that, in the third step, we have to do the translation once again. From the origin of the viewport, we have to place the image in the correct viewport position or its final position. Now in this video, we will learn about how to calculate this point. Okay. Suppose a point on window is xw, yw and the corresponding point on viewport is xv, yv. So we need to calculate the point xv, yv from the xw, yw. Okay. So in order to maintain the same relative placement of the point in the viewport as in the window, it is required to calculate the relative position of the point considering offset from the origin and ratio of window and viewport. Offset means how far that point is from the origin in terms of x and y. That will help us in the translation. And ratio of window and viewport, this will give me the scaling factor, how much more large or how much smaller I have to make my image. Let us check one example. Suppose this is my window and this point is xw, yw. Okay. And this point is xw mean, yw mean, the bottom left point. And the top right point is xw max, yw max. Okay. So, and similarly, this is my viewport. As we can see in naked eye is that this viewport is smaller than the window. The bottom left corner of the viewport is xv min, yv min, and the top right corner is xv max, yv max. We are saying that this point xv, yv, that is equivalent to xw, yw. Okay. So for that thing, what I have to do, I have to calculate these distance, the x distance of the point from the origin. What is that? This point is xw and this point is xw min, right? So this distance is xw minus xw min. Okay. And similarly, what about this distance? This distance is xw max. Then we have to calculate the total distance. What is the total distance? Xw max minus xw min. Similarly, in the viewport, what is this distance? How far is the point from the xv min? That is xv minus xv min. This distance is xv minus xv min. And what about the total distance? That is xv max minus xv min. To maintain the relative position of the point, what we have to do, this distance by the total distance, this ratio should be equal to this distance by the whole distance, this ratio. Okay. So xw minus xw min whole by xw max minus xw min. This by this. That should be equal to this by this. xv minus xv min by xv max minus xv min. Okay. Similarly, we have to calculate the y values. yw minus yw min. That means this distance by the whole distance, that should be equal to this distance by this whole distance. Okay. So yw minus yw min by yw max minus yw min, that should be equal to yv minus yv min by yv max minus yv min. Okay. So this is the calculation for xv and yv. Now from this equation we have to calculate the value of xv and yv. So let us take this portion. These should be multiplied with this whole quantity and then xv mean will be added, right? So xv equals to xv mean plus this one into this whole quantity by this value, right? So if I simplify this equation, I will get this. Similarly, okay. Now this ratio, that is xv max minus xv mean by xw max minus xw mean, or the length of the viewport by the length of the window, we will call it as the scaling factor in x direction, or Sx. We can write like xv equals to xv mean plus xw minus xw mean whole into Sx. X is known as the scaling factor or the resizing factor of the x coordinate. Similarly, I can calculate for yv and as well. Yv equals to yv mean plus yw minus yw mean whole into yv max minus yv mean by yw max minus yw mean. Or simplifying, we get yv equals to yv mean plus yw minus yw mean whole into sy, where sy is yv max minus yv mean by the height of the viewport by height of the window. Sy is known as the scaling factor or resizing factor of the y coordinate. Okay. Now let us consider one example. You have to practice more. Okay. Given if the window is xw mean equals to 0, xw max equals to 4, yw mean equals to 0 and yw max equals to 2. And the viewport is xv mean equals to 60, xv max equals to 380, yv mean equals to 80 and yv max equals to 240. What is the viewport value of the point 3.4, 1.2? So this is my point in the world coordinate system or in the window. Okay. So first of all, what we have to do, we have to calculate the scaling factor of x coordinate Sx and scaling factor of y coordinate Sy using the formula. So Sx will be 380 minus 60. That means the xv max minus xv mean, xv max minus xv mean 380 minus 60 by xw max minus xw means by 4 minus 0. So it will come like 80. Similarly, Sy we have to calculate, right? Sy we are also getting same value 80. So now we have to calculate the point on viewport, that is xv by v. xv equals to, what is the formula? Let's go back. xv equals to xv mean plus xw minus xw mean whole into Sx. So xv equals to 60 plus 3.4 minus 0 into Sx, that is 80. If I calculate, I will get the value like this. 60 plus 272 whole equals to 332. Similarly, yv equals to 80 plus 1.2 minus 0 whole into 80. 80 plus 96 equals to 176. So the equivalent point of 3.4, 1.2 in the world coordinate, the equivalent point in the viewport is 332, 176. Okay. So you can solve some similar problems, right? That is about how we are calculating a point. Now we are coming to the second topic, that is matrix representation of viewing transformation. My first step was the translation, right? We were moving the lower left corner of the window to the origin. So if the lower left corner of the window is xw mean, yw mean, then the tx or the translation factor in the x direction, that will be minus xw mean. That means I have to go xw mean backwards towards origin. Okay. Similarly, the ty, that will be minus yw mean. So these are my translation vectors. what is my step 2? Resizing or scaling. We have to resize the scene of window to the viewport. We have already shown that A6 equals to xy max minus xv max minus xv min by xw max minus xw min. Similarly, sy equals to yv max minus yv min by yw max minus yw min. Okay. And what about the third step? That is translation. Once again, we have to move the viewport to the desired location on the screen. So if the bottom left corner of the viewport is xv mean and yv mean, then my tx will be positive xv mean. From window we have to go towards xv mean and xv max. Ty will be yv mean, right? So xv mean and yv mean are the translation factor in the viewport, or the second translation factor. I want to represent this whole thing in matrix. So if I want the matrix representation of the viewing transformation, above 3 steps, those can be represented in matrix form. How? Vt equals to viewing transformation equals to first translation into scaling into second translation. First translation, that stands for translating window to the origin. And what is the matrix for that? 1, 0 minus xw min, 0, 1 minus yw min, 0, 0, 1. We have used these homogeneous coordinate system, and we have already calculated the translation factors tx and ty, right? Similarly, what will be the scaling factor in case of using homogeneous coordinate system? We have to write like this: sx 0, 0, 0, sy 0, 0, 0, 1. In our case, sx and sy we have calculated, right? And what about the next translation? This will be positive xv min, positive yv min. So 1, 0 xv min, 0, 1 yv min, and 0, 0, 1. This is the column representation of the matrix, right? So now we will check one example of how to perform the viewing transformation using the matrix. Suppose there is a rectangle ABCD whose coordinates are A 1 1, B 4 1, C 4 4, D 1 4, and the window coordinates are 2 2, 5 2, 5 5, 2 5. Okay, and given the viewport location is 0.5, 0, 1, 0, 1, 0.5, 0.5, 0.5. We have to calculate the transformation matrix. What is the first step? We have to translate the left lower corner, that means this corner, to 0 0. What will be the shift vectors? -2, -2, right? I have to come back 2 units this way and 2 units this way. So the in matrix format we can write like 1 0 0 0 1 0 -2 -2 1. Okay, so first matrix is done. What about the second matrix? Step 2 is scaling of window to viewport. Scaling in x direction sx, that is width of viewport by width of window. That means 1 minus 0.5 whole by 5 minus 2, or that equals to 0.5 by 3. The value will be 0.16. Similarly, scaling in y direction sy equals to height of viewport by height of window. So 1 minus 0.5 by 5 minus 2. So the 1 minus 0.5. The height of window, just a sec. Height of the viewport. What is the viewport? Yes, 1 minus 0.5 by 5 minus 2. What is the coordinate? This is y is 5 minus 2. Yes, 5 minus 2. So the value is like 0.16. So the scaling matrix will be 0.16 0 0 0 0.16 0 0 0 1. This is the scaling matrix. Now we have to calculate the third matrix, that is the translation matrix. We have to translate the origin of the viewport to desired location. We have to translate the 0, 0 point to 0.50. So the shift in the x value is 0.5 and shift in y value is 0. In matrix format, it will be 1, 0, 0, 0, 1, 0, 0.5, 0, 1. Okay. Now, weaving transformation matrix would be multiplication of these three matrices. Okay. So, after performing the matrix multiplication, we will get the resultant matrix like this: 0.16, 0, 0, 0, 0.16, 0, 0.18, minus 0.32, 1. Okay, so this is the resultant matrix. So that is all about two-dimensional viewing transformation. If I consider the two-dimensional viewing transformation pipeline, we can say all the elements are modeled using the modeling coordinates. Then the void coordinate scene is constructed from modeling coordinate transformations. Then it is converted into viewing coordinates from the void coordinates, then the viewing coordinates to normalized coordinates, so that we can use the same thing for all the devices. Then from the normalized coordinates to, we have to map it to the particular devices, and it is finally in the device coordinate system. So that is all about two-dimensional viewing transformation from window to viewport. Now, in our next lecture, we will learn about the clipping algorithm. That means how to remove the portions outside a given window. We will learn about that. Okay. If you have any queries, you can ping me anytime. Okay. Thank you.